Welcome to Cambridge IGCSE Physics, Lesson 27.1, Reflection of Light, Terminology. Today we explore the fundamental vocabulary and concepts needed to understand how light reflects from surfaces. This is core content for your examination, focusing on precise scientific terminology and accurate ray diagram construction. We will learn to define the normal, angle of incidence, and angle of reflection. These terms form the foundation for understanding reflection phenomena in physics. By mastering this terminology, you will be able to communicate scientific ideas clearly and solve reflection problems systematically. Let's examine our learning objectives for today. By the end of this lesson, you will be able to, first, define and use three key terms: the normal, angle of incidence, and angle of reflection. These definitions must be precise and complete. Second, draw accurate ray diagrams showing reflection. This includes proper use of rulers, correct arrow directions, and clear labeling. Third, measure angles correctly using appropriate technique with a protractor. This assessment focuses on three objectives. A01 tests your scientific knowledge and vocabulary. A02 examines problem solving and pattern recognition, and A03 evaluates practical skills including diagram construction and angle measurement. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, the normal, pronounced normal, is the perpendicular line drawn to the reflecting surface at the point where light hits. Perpendicular means at 90 degrees to the surface. Second, the angle of incidence, pronounced incidence, is the angle measured between the incident ray and the normal. The incident ray is the light ray approaching the surface. Third, the angle of reflection is the angle measured between the reflected ray and the normal. The reflected ray is the light ray bouncing off the surface. All angles are measured in degrees, using the symbol for degrees. Understanding these terms precisely is crucial for examination success. Let's explore our first core concept, the normal. The fundamental principle states that the normal is the reference line for all angle measurements in reflection. This means every angle we measure must be taken from this line, not from the surface itself. The definition is a straight line drawn perpendicular to the reflecting surface at the point of incidence. Perpendicular means at exactly 90 degrees. The point of incidence is where the light ray hits the surface. Key properties include: first, it's always at 90 degrees to the surface, regardless of surface orientation. Second, we draw it as a dashed line to distinguish it from light rays. Third, it's essential for accurate angle measurement. The diagram illustrates these features clearly. Notice the right angle symbol showing the 90-degree relationship between normal and surface. Now we examine ray diagram construction. This follows Cambridge IGCSE standards precisely. The equipment needed includes a ruler for straight lines, a protractor for measuring angles, and a sharp pencil for clear lines. The method consists of these steps. First, draw the reflecting surface as a straight line using your ruler. Second, draw the normal as a dashed line perpendicular to the surface. Third, draw the incident ray approaching the surface with an arrow showing direction. Fourth, draw the reflected ray leaving the surface, also with a directional arrow. Conventions are important. Arrows always show the direction light travels. Safety is essential. Handle equipment carefully and keep sharp points away from your eyes. The diagram shows a complete ray diagram with all components labeled clearly. Let's work through our first example of angle measurement. The problem states, light hits a mirror and the incident ray makes 30 degrees with the normal. Find the angle of reflection. We are given the angle of incidence equals 30 degrees. We need to find the angle of reflection. Step 1. Identify the principle. The law of reflection applies to this situation. Step 2. State the law. The law of reflection states that the angle of incidence equals the angle of reflection. Step 3. Apply the law. Therefore, the angle of reflection equals 30 degrees. Step 4. State the answer. The angle of reflection is 30 degrees. Remember, both angles are always measured from the normal, never from the surface itself. Protractor technique is crucial for accurate measurements. The problem is, measure angles accurately using a protractor in reflection experiments. The method consists of 4 precise steps. First, place the center point of the protractor exactly on the point of incidence where the ray hits the surface. Second, align the baseline of the protractor with the normal line, not the reflecting surface. This is critical for correct measurement. Third, read the angle scale carefully, ensuring you read the correct scale if your protractor has 2. Fourth, record the measurement with proper units in degrees. The common error students make is measuring from the surface instead of the normal. This gives incorrect results. The diagram shows correct protractor placement, with the center on the point of incidence and baseline aligned with the normal. Understanding terminology in context is essential for examination success. Let's examine a complete reflection description using all terms correctly. The example statement reads, "The incident ray approaches the reflecting surface and strikes it at the point of incidence. The normal is drawn perpendicular to the surface at this point. The angle of incidence is measured between the incident ray and the normal. The reflected ray leaves the surface, and the angle of reflection is measured between the reflected ray and the normal." This statement demonstrates proper use of all key terms. Key points for examination answers. First, use complete scientific terminology, not abbreviated or casual language. Second, specify measurement references clearly, always stating that angles are measured from the normal. Third, include all relevant components in your descriptions to earn full marks. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, define the normal in reflection. This tests your understanding of the fundamental concept and requires a complete, precise definition. Question 2 is intermediate level. It states, draw a ray diagram showing 40 degrees incidence. This requires you to apply the concepts we've learned, constructing an accurate diagram with proper angles and labeling. Question 3 is advanced level. The question is, explain why angles are measured from the normal rather than from the surface. This tests your analytical understanding of the reasoning behind our conventions. For all questions, remember to use precise scientific terminology and include units where appropriate. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how today's concepts apply in practice. In mirror technology, bathroom mirrors and optical instruments use reflection terminology for precise design. Engineers must understand angles of incidence and reflection to create effective mirror systems. In submarine periscopes, precise angle calculations ensure accurate viewing. The terminology we've learned today is essential for calculating the correct mirror positions and angles. In solar panel technology, optimal angles maximize light reflection control, improving energy efficiency. Understanding reflection terminology helps engineers position panels for maximum effectiveness. Career-wise, these skills lead to optics engineering, designing telescopes and cameras, astronomy for space observation systems, and telecommunications for fiber optic communications. The precise measurement, technical drawing, and scientific communication skills you develop here become professional tools. Let's review the solutions. For question 1, the answer is, the normal is a straight line drawn perpendicular to the reflecting surface at the point of incidence, used as the reference for measuring angles. This definition includes all essential elements: straight line, perpendicular relationship, location, and purpose. For question 2, the solution requires drawing the surface as a straight line, the normal as a dashed line perpendicular to the surface, the incident ray approaching at 40 degrees to the normal, and the reflected ray leaving at 40 degrees to the normal on the opposite side. For question 3, angles are measured from the normal because it provides a consistent reference regardless of surface orientation, ensuring universal application of reflection laws. This explains the scientific reasoning. Exam success tips. First, define terms completely including all key words. Second, draw diagrams using a ruler with clear labels. Third, always measure angles from the normal, never from the surface. Fourth, state units for all angle measurements using the degree symbol. Let's summarize today's lesson. The key points to remember are, first, the normal is the perpendicular reference line for all angle measurements in reflection. It's drawn at 90 degrees to the surface at the point of incidence and serves as our measurement baseline. Second, angles are always measured from the normal, never from the surface itself. This ensures consistency regardless of surface orientation and allows universal application of reflection principles. Third, precise terminology is essential for clear scientific communication. Using correct definitions demonstrates understanding and earns examination marks. For further study, practice drawing accurate ray diagrams using proper equipment and techniques. Review angle measurement methods with a protractor. The next lesson covers the laws of reflection, which builds on today's terminology by introducing the mathematical relationships between angles. Ensure you understand today's definitions before progressing, as precise terminology forms the foundation for all reflection studies.